Dear all, welcome to this new episode of CATIA Talk for construction. This time we will welcome Thomas Bergeron, who is a Director of Industry Solutions, focusing on productization. We will discuss about CATIA for productization, which is one of the new strategy which is taking place in the construction industry all around the world. We will discuss about different topics for this strategic endeavor. In this CATIA talk, Thomas Bergeron will present the concepts that evolve around productization, how it works, the principles, the solutions that are used for productization. We will see productization in action, collaboration and design review on a productized mockup, and productization with one of our Dassault Systèmes pioneer, Wood & Co. I just want to emphasize the fact that this is our first episode for productization, because productization is a pretty big topic in the construction industry, and there will be a second one with a deep dive into other topics of what we just presented. This CATIA talk will be held here in the post of our CATIA Building and Infrastructure community, but will also be held on our CATIA YouTube channel and our CATIA LinkedIn channel. So don't hesitate to watch or rewatch this CATIA talk, and of course don't hesitate to forward the link to your business ecosystem. Thank you very much for watching, and we wish you an excellent day.
Hello all. Thank you for joining this CATIA talk. I am Thomas Bergeron. I belong to the AEC industry as a technical director. And today we're going to talk about productization. This is our strategy that we push forward today in the AEC industry. So in order to talk about productization, I have prepared on my 3D Experience platform actually a dashboard with several tabs. We're going to talk about the principle of productization, the how-to explain some technical stuff, to see productization in action, how we can collaborate around productization, do some design review, design changes, talk about interfaces, and have a quick review on the productization community. So let's start about the principle of productization. And actually, to start to talk about productization, I'm going to show you a very surprising illustration. Last week, we had a team meeting, and the goal was we had a small exercise game. And the question was, which piece of art would you choose to illustrate productization? And actually, I'm going to show you which piece of art I have selected. So let's go. Here we go, Mona Lisa. This is quite surprising. So actually, I didn't select this exact image that you see, because this image here, so it's a beautiful piece of art. Everybody knows it. It's unique. It's great. And actually, the one that I've chosen is not this one exactly. This is the artist view, like the architect's view. The one that I've chosen represent the construction view, the one that we use to fabricate this Mona Lisa. Okay, so my first message here, what is it? Is that productization will not drive the aesthetic or the shape of the building. You can have a bespoke building, okay, a very famous building, thanks to productization. Productization is not just boxes, okay? So let's have a look at the construction view of Mona Lisa. Here we go. So this was actually the picture that I've selected. And maybe you start to understand. This nice piece of art here is composed, so this is a puzzle. So productization is getting closer to a puzzle. And actually, if you look here, this puzzle is composed of many, many different pieces. And all these pieces, you see, needs to adapt to adapt their shape to their context. So they all have a different shape. It's adapting based on their position inside the painting to adapt. And at the same time, it's connected with other pieces thanks to small interfaces here. So each piece has its own interfaces with the other pieces around it. This is productization. So if instead of calling pieces these small blocks, we call them bricks. And actually, productization is around bricks, is around how you're going to assemble a set of bricks together and connect these bricks together to make sure that these bricks adapt to their context and resolve automatically their interfaces with the other bricks. So if we look and if we make the analogy with building, we have our puzzle. And so the productization is about dividing your building into bricks. What is a brick? A brick, it's a system inside your building that provide one or several services. It can be a structural services, it can be aesthetical service, it can be acoustic, phonic, thermic service. But all these pieces and these systems are connected to each other. So we have our puzzle here, and the goal of productization is to divide this building into several systems, bricks. Here, for instance, we can have technical risers, precast slabs, facades, partitions, water distribution systems. In fact, you have dozens of systems in the building, but each of these systems are reused project to project. So the goal of productization is to capitalize on each of these systems to be able to reuse them from one project to another, to another, to another. The goal here is to reduce the cost, to reduce the engineering study, and to facilitate the work on the construction site. So all these pieces, the goal of productization will be to capture the knowledge and know-how on how to fabricate these pieces, okay? Because they are reused from project to project. If we are able to capture the engineering and the construction know-how on how to fabricate these pieces into a smart component, a brick, then the reuse will be very easy from project to project, okay? So with productization, we target actually, so the construction site, okay? In order to capture the construction methods on how, for each brick, okay, we want to capture the knowledge and know-how of each brick, how it is fabricated. We want to masterize the interfaces on the construction site and to ease the worker's job on the construction site, okay? So productization, it's about the how to standardize the methods of creating all these bricks. So the goal here, if I just play this little video here, it's to bring on the construction site all the knowledgeable information to fabricate the building. So all these bricks will provide knowledgeable information such as bill of material, quantities, resources needed for each phase of the construction site. So each bricks needs to be very detailed because this is the detailing that will help us to solve all the issues, okay, all the interfaces between these bricks. So just to quickly summarize these key facts. Productization is targeting the construction view of a building, the how. It is not influencing the aesthetic of a building. It relies on bricks that interact each other through interfaces. Productization is about capturing the construction methods of each brick. So each brick will be fabricated off cycle. We will capture all the knowledge, engineering knowledge, construction site know-how put that in a brick, and then we'll reuse it from project to project. So the bricks will deliver all the information for their fabrication and installation and integration on the construction site. That's why these bricks are very high level of detail. Okay, so they will provide deliverables such as BOM, work instruction, resources. And this is what you see here on this video. This is the level of detail that these bricks will provide to the construction site manager, because all the needed information are in the details. How you will integrate, facilitate the interfaces between an electrical plug here inside a concrete wall. This is all these detailed interfaces that we need to solve before the construction site. And that's why the bricks needs to be very detailed in order to manage all these interfaces. Okay. So let's continue. So how does it work? So basically, we have a life cycle team that will produce these bricks, okay, which contains the complete know-how. And then once we have a project, this brick will be instantiated inside the project in the construction virtual twin. So because these bricks are adaptive, generative, and parametric, it will automatically adapt to the context of the project. We will solve the interfaces of the brick, and then it will deliver the right information for the construction site manager, such as the BOM, the parts list, the work instruction, in order to facilitate the worker's job. Okay. So what's inside a brick? A brick has some inputs. The first input, it will be the geometrical context. Where we're going to use this brick, in which context. Okay. Then it will have to connect to external interfaces to adapt itself to its environment, and also some technical specification, because a brick is parametric. Okay. You might change the configuration of the brick. It needs to be adaptive to adapt to its context, and sometimes generative when the topology of the context change from one project to another project. So the bricks might need to be generative in order to create on the fly new parts. And inside this brick, there is a lot of know-how. The field know-how, it means all the fabrication best practice, the material and human resources needed to install these bricks, and also all the engineering rules, legislation, regulation, standards, and stuff like that. And because a brick is very detailed, it has also to capture, okay, to collect all the commercial products from the catalogs, okay, and import this data into the bricks, because a brick is mainly composed of standard components. These standard components will be transformed or not transformed. It means cut, drilled, but some of them will just position into the bricks. And the brick will deliver construction deliverables such as a BOM, quantities, work instruction, installation drawings, and so on. And of course, also interfaces for other bricks to be connected to. So if we take an example of a wood facade, this is an exercise that I've done with one of our pioneers, Wood & Co. So we created a wood facade brick. The wood facade brick here is using a wall coming from a Revit or an IFC file. So here we have a generic wall, okay? This is just a solid, dead solid. And what the brick will do, inside the brick, we have a generative skeleton. It will automatically analyze the shape of the input of the wall, automatically detect all the interfaces for windows or doors, automatically, based on field know-how and engineering rules, compute the position of all the standard parts inside the brick, position the standard parts accordingly, And transform, it means cut, drill, or make other operation on the standard parts to create the final results. So this brick is capturing, so of course, the transformable parts, such as the piece of wood that have specific standard for the sections, but they are transformable because inside the brick, we're going to automatically cut them or drill them at the right size. And also, we're going to use not transformable standard parts that will be just inserted in the brick and positioned automatically at the right location. And the brick will deliver a BOM, cut list, a drawing installation, and some work instruction. So this is an example of the brick. So let's see that now in action. So here we have a context. Here we have imported into the platform an IFC file. So we have all the, and what we have isolated, okay, all the facade walls. But these facade walls needs to be performed as a wood facade. And what we are doing here, we have attached the construction method, it means the wood facade, to each piece of facade coming from the IFC. So here, the facade that you see in transparent, we have attached the wood facade brick. And what we are doing, we are automatically instantiating this brick. And let's see, in fact, the different action that happens during the instantiation. First of all, the system import the brick into the context. So you see here, the brick is not positioned. Then you see automatically the brick has detected the interfaces of the wall on which we want to create this stud facade. You see the purple curves here, contour. They have, it means it has detected the windows automatically with the size. Based on that, the brick is analyzing the wall. It has computed the position of each of the members and instantiated each members and cut it at the right dimension. But yet it has not yet solved the interface with the windows. And here you see it has started to provide the right solution for a specific opening. For a window, we have some specific trim to instantiate. And the brick is doing that automatically in a generative way. For each window, it will instantiate the right solution. The brick detects the interface. And because we put some knowledge, it knows how to solve this interface. So now it has solved the interface, and now the brick will transform all the pieces to create the final result. And you see here we have some studs in the middle of the openings. Of course, we don't want that. So this is where the brick will finally transform and generate the deliverables. And you see automatically it will provide the right result. All of that, and you see at the same time with all the quotation and the fabrication drawing here with the parts list and so on. So this is just an illustration of the instantiation of a system inside a building. So productization, it reduces significantly the engineering work on a new project. We have captured the engineering work one time, and then we can just reuse project to project. We minimize it, so it minimizes the interface at the construction site. Because the bricks have already solved the interfaces inside them, we just have few interfaces at the construction site. When the brick is delivered at the construction site, so it can be delivered in different way, as a kits of parts, pre-assembled, prefabricated. And in fact, so what we see is the construction site becomes an assembly site where the kits of parts or the prefabricated modules arrive, and we're going to assemble together. So this is an assembly job. It's no more a traditional construction job. So it facilitates significantly the worker's job on site. So it reduces a lot the construction phase and then reduce significantly the cost of a project. So now let's go a little bit more into the technical, in the how-to. So we have seen that inside a brick, we might have a generative skeleton. So what do we use to create this generative skeleton? So here we have, for the wood facade, you see, we have the input. And in fact, we create a design sequence. So this is X generative design or visual scripting. This is the solution that we have in the 3D experience platform to automatically recognize the complete topology of an input. So here we have the wall. Automatically, we're able to identify its position, its orientation, to identify the different openings. And then it's very easy to differentiate here the openings, the doors from the windows, because the interfaces might be different. The solution that we want to instantiate on a door or on a window might be different. So this is why we are differentiating the window with the doors to provide the different solution. In this generative skeleton also, we compute automatically the position of all the different standard parts. And so after, it's very easy to import the part, position it, and put it in position. So all this is done on a generative manner. It means whatever the wall, the input is, the topology and the input, we will recompute everything automatically. This is the power of the 3D experience platform. So this is a generative skeleton. We might also use more standard approach with a parametric skeleton. So a parametric skeleton is just using point, lines, and axis system to define, in fact, the position of the standard parts of a brick. We would use a parametric skeleton where the input and the context of the brick is very constant from a project to another one, where just dimensions changes, but not the topology. So here we see that we create a parametric brick. Everything is associative. It's very detailed, of course. We have all the components, and of course, we can embed know-how rules, okay, into the brick to provide a specific behavior based on engineering standards and stuff like that. Okay. Here we go. Another solution, this is the generative part placement. Generative part placement, this is very powerful. Here again, we're gonna, so this is a concrete wall brick that is automatically, that we are using on an IFC file. So automatically it detects all the openings of the wall. The brick will dimension automatically all the openings, okay, to create the formwork drawing automatically. And at the same time, because in the brick we have captured a lot of knowledge, we are able automatically to position standard modules of rebars automatically at the right position, location, and dimension. And this in a generative manner. So this is extremely powerful because here with one single brick, you can in fact create the rebars of hundreds of walls. Okay. Okay. The other topic that I would like to discuss and to present you is part supply. This is the capability when you fabricate a brick to be able to directly access a supplier catalog to select a very specific parts from the supplier catalog and insert this part directly into your design. So here, we're gonna select a connection angle with 2 holes. So directly from part supply, we are able to change the configuration, to select a standard configuration that we want, to review the technical specification of this connection and import it directly in our session. So automatically the part is converted, inserted into our design. And if we re-import it a second time, we will use the same reference. So then we can, of course, quickly reuse this part into the design, position it exactly where we want. And so it facilitates significantly, in fact, the work of the designer to be able to directly access the supplier components. Okay. So let's see productization in action. So you have seen some of it, and now I'm going to review and comment a video that I posted recently on the different media. It's about creating a building module using productization. So actually, the goal here was to illustrate to our customer the productization approach. So here what we have on a module. And here what we have created a skeleton, a parametric skeleton to define, in fact, the bounding box of the module. And right on this module here, so I am building some steel connection to create the steel structure of the module. But what's interesting, it's a little bit after, it's the way we're going to use, in fact, several bricks to fabricate this module. What's interesting in this video, it's the brick that I've used. None of them were dedicated to this project. It's just reuse of bricks in a totally new environment. So here what I'm doing, I am illustrating the architect's view, creating some very basic wall, okay? But on this basic wall, I attached a specification. This is an object type. And what it means, in fact, this basic wall from the architect definition, we are attaching a construction method. It means a brick. This basic wall will be a wood facade. Okay? So in fact, just by attaching a specification, a construction method to this wall, I will be able to create automatically my wood facade. So we're doing that with these two walls. At the same time, so we are attaching other specification for the partition. So here you see the small icon. So here we have defined also, say, on this line, I want a partition, and a partition. And automatically the system will search in the brick catalog and instantiate the bricks. Automatically, they will adapt to their context. So you see they are imported and automatically their sizes adapt to the right context, to the right position with the right engineering rules. So it's very fast, very powerful. And here we know that each of these elements are fully fabricable, okay? Of course, each brick have some configuration parameters that are open to the user to change the configuration, okay? And each brick delivers the fabrication assembly, okay, with all the parts list in order to be fabricated on site or in a factory, okay? Here, what's interesting, I want to instantiate a ventilation brick. And you see this ventilation brick has some inputs, okay, to adapt to its context. And here, automatically, the system has detected all the inputs needed to instantiate this brick. Thanks to the naming convention on interfaces, automatically it detects where it has to position this ventilation brick. So automatically it's positioned correctly, okay, against the wall between the bathroom wall and the facade. And now the user can, through parameters, just adapt its position. Of course, this is a detail brick, and here we're instantiating all the detailing of this ventilation with all the different components you see of the ventilation system, the fixation, the duct, the elbow, and so on. And of course, this is fully parametric. So here you see zero engineering study. You just have to pick a brick from a catalog and instantiate it. What we're doing here, we're changing the architect's intent. We are adding a door into the architect's wall. So this is the architect view. In the background behind, you see the facade, which is the construction view. Okay. So here, what we are doing very quickly, we are modifying the architect's definition by adding a door or a window. At the same time, in this wall, we see that the ventilation brick here is publishing an interface. Okay, and we're going to use this interface to create the wall, to create the opening inside the wall. Okay. So this is the architect definition. And now the goal is to propagate automatically this modification into the construction view. And you see here that the brick has detected the opening. You see here the black contour with the cross here also. So automatically, the brick has detected the interfaces for the window or for the ventilation and will provide automatically the solution for these two interfaces. Okay. So this is very powerful because here you don't have to do again a new engineering study. Automatically, you pick the right solution. And you see automatically the quotation have been recomputed. So the drawing will be, you don't have to retouch the drawing. All the quotation will be updated automatically. So here we see the connection between a ventilation brick and the facade. This is exactly the puzzle with the two bricks interfacing each other. I modify the position of my ventilation automatically. My facade is updating and following this modification. Okay. Okay, so let's stop with this one. And of course, just to finish it, this is fully parametric. So if I change the size of the module, okay. So here we extend, we create a brand much bigger module here. Automatically, everything will follow. Because these bricks are generative, it will compute new studs for the partition, for the facade, and everything will update. All the bill of materials will update automatically. Okay, so this is the power here. It's the adaptability of the bricks to a new context, to be able to recompute themselves and to still manage the interfaces between each other.